All right, last thing, and this is a very short section. So, up until this point, listen. We have two different ways to decide if it's normal. With proportions, how did we check that something was normal?
It's random.
The CLT, which how did I check that mathematically? N times P, N times 1 minus P is greater than 5. Whenever I have means, how did I check that?
30.
N is greater than 30. What was the other way? It's given to you that the population is normal. There is now a third way, okay? We're learning the third way today. So if it's not given, if my sample size is not greater than 30, I can check if it's a normal distribution mathematically by graphing it on a normal probability plot. So this came up, I think, in the first or second chapter where you looked at it. You looked at a normal probability plot and you wanted the points to be linear. Do y'all kind of remember that, looking at it? So we're going to look at a few of them. It's just called a normal quantile plot, normal probability plot. That's what I mean by that, where it's taking all of the z-scores and it's graphing them for you. So I'm going to show you how to look at a graph and decide if it's normal. I'm also going to show you how to graph one yourself. So here we have figure A and figure B. I'll be done by then. Okay, let's look at figure A. So you have the picture in front of you. These points along the line, they form a linear pattern. So I would say that this is normal. So since the normal probability plot is linear, or is approximately linear, the data is normal. I want you to write that sentence. What about B? Does it look linear? No, it forms a pattern. So since the normal probability plot is not linear, the data is not normal. Here we have a histogram. Oops, no, not this one, this one. We have a histogram and a normal probability plot. So this is the original data. Then they put that data onto a normal probability plot, which is this figure right here. Whoa. I don't know why it keeps going away. There we go. So, what would I say about this? Is the data normal or not?
No. It's right skewed.
Since the normal probability plot is not linear, the data is not normal.
Can I write an acronym?
Nope.
No.
I think they all
Yeah, can we write that? Not normal, so it's not linear. Not linear. So
Yeah, not linear, not normal. Okay, next one. Let's look at these 4 graphs. What do you think about the top left hand?
No. The bottom right.
Kind of does that. So I'm going to say not linear, not normal. What about top right? Not linear, not normal. Bottom left. Yes, it's good. Linear, normal. What about bottom right?
Yes.
Yes, linear, normal. No.
Yes.
Okay, last part. So that's being able to identify. Now we're going to create one. So what I want you to do in your calculator is I want you to take all of these data points and put them in one list.
So stat.
One list.
Stat block.
Stat edit. Put them in one list. So not two lists, just one. So how many numbers are there? 24. There's 24 data points. That's less than 30, so I need to check it graphically. Yes.
Did you watch your calculator just flat?
I'm going to go to second y equals. Plot should be turned on. And the type is the bottom right-hand graph.
You gotta select it. Wait, you said the bottom right?
Bottom right.
I can't get to the bottom right.
Oh, wait, no, you just have to keep going right.
Yeah, just keep hitting the right arrow.
Then graph.
Then zoom 9.
Oh, wait, who?
Mine said error 10 times.
I'll have to look. Check and see if there's something in your y equals.
Oh.
Wow, Miss Thornhill, look.
Good.
It ain't it.
How do you draw a line?
Good.
Wait, is data access supposed to be X?
I know you
Yes,
do that.
L1.
How do you make a list? Question.
Go to stat. It
Okay, what I want to do now is I want to draw it.
ain't it.
Hold on. If you cannot get your calculator to work, just wait 1 minute and let me draw this for you.
Wait for the stat wizard.
So, you are going to create your graph. I'm going to draw it like this. And I'm going to approximate the dots. Okay? I don't need numbers or anything like that. Where my y-axis are my z-scores. Yes. My y-axis are my z-scores. And then my x-axis is whatever we're measuring, which I don't know what we are.
Percentages.
Number of hours spent studying. So hours studying. So this is always my x. The x-axis is my x. The y-axis is my z-score.
All right, we got it too.
If I have, okay, so my horizontal line, my x-axis is 0. What does that mean if it's on 0? That it's, if you have a z-score of 0, then you are what?
Normally distributed.
No, you are,
Under the average.
you're the average if you have a z-score of 0.
Or, if you have a Z-score, I think it's under 0.
And then if you're above 0, you're above average. If you're below 0, then you're below average.
Way below average. I need to
So I would say since the normal probability is linear, the data is normal. All right, I want you to try one more. Okay, so this is what yours should look like. When I am grading this, I need all eyes right here. Close your eyes. When I'm grading this, I will be checking the graph, the dots. I'll be checking that the axes are labeled and the sentence. Now, how I will go about this is I will throw a question out there that has to do with means, because this is only for means. So this goes with 6.4b. And I will give you a scenario, and you have to decide if it is normal because of one of the three options. There are 3 ways that means can be normal. So when I'm talking about means, it can be normal if, ... given n is greater than or equal to 30, or you have to graph the normal probability plot. It's going to be one of these 3, and you have to discern which one. Okay, I'm not going to tell you which one it is. You have to know. If it's proportions, There's only one way. It's normal if
It's like NP.
NP is greater than or equal to 5, N times 1 minus P is greater than or equal to 5. So proportions, you have to show it mathematically, means it's going to be one of the three. So even if you have a sample size less than 30, you can still graph it if it gives you the original data. Or, like on the quiz, it told you that the population was normal, so you could have kept going.